Hello everyone, welcome to the webinar. Today we will discuss Unit 2 in geometry, and Unit 2 is about polygons and triangles. So today we will look at the most challenging topics in this unit that deals with polygons and triangles, and try to understand more and try to create a discussion that by the end of the webinar you're able to go back to your study unit and read more and understand more and get ready more for the exam. My name is Mariam. I'm a math instructor here at Penn Foster. I'm certified to teach high school mathematics in the state of Pennsylvania. I'm working towards my master's as well, and I'm excited because this year I should earn my degree. Today in this webinar, as I said, we're gonna discuss the most challenging topics in this unit, but it's not gonna cover everything that you need to know for the exam. So you still need to study, you still need to do the practice exercises or the self-checks, you need to check your answers, you need to do the work that you're supposed to do. This webinar just a supplement for you to touch upon the ones that I get the most questions on. During this webinar, we're going to have a self-assessment questions, and those questions are not graded. So after certain discussions, you will be presented with one question on that topic, and we will allow like a minute or so for you to try the question and see where you are, where you're standing in that topic. If you are good at the topic, you feel the question is easy, you had your answer correct, then you are ready in that topic. If you have your answer incorrect, it doesn't mean that you will never get geometry. It just means that you need to prepare more for the exam. So those questions are only self-assessment questions, so please participate. Questions are also welcome. Please keep them relevant to what we are speaking about at that moment. You can send your questions through text in the questions box. The raise your hand feature is not enabled. So if you have a question, you really think it's a question that everyone will benefit from, please type it and I'll see the question and I'll see the sender of the question. All registrants, whether you attend today or you didn't happen to have the time to attend the live webinar, will receive a recording for this webinar. Today we will look at how do we calculate the interior angle measures of polygons and regular polygons as well. We will look at triangles. We'll see the two formulas that we are presented to in this study unit to calculate an area for a given triangle. We will look at an area of a polygon. We're going to look at the Pythagorean theorem. And also we're going to look at the similarity when it comes to polygons and triangles. What are the rules that we have to go by if we are talking about similar polygons or triangles? Let's start then with the first topic, which is it's a mild kind of topic. It's not the worst topic they're going to see, but I still see students have some kind of confusion on how to use the formula in gray that you see here on the screen. So typically the question will ask you, what is the sum of the interior angles in a given polygon? In that question, we need to use a formula. And really for this course, I should say, for this course, it's not an advanced course in geometry. It's really an introductory course in geometry. What we need really to know is to pick out the right formula for the right question. So if you have a question like that, what is the sum of the interior angles of the given polygon? Right away, my mind is going to go to that rule. The sum, S, equals to 180 degrees times n minus 2. I don't have to invent that theorem or that fact. I just need to find it and use it correctly. So the sum is what we're trying to do, and the sum of the interior angles are those angles inside. So this is an interior angle, and this is another interior angle, and so on. So if I'm going to add the sum of all the interior angles for the given polygon on the figure, it should give me a value in degrees, which is the S. Now we need, for this formula, we need n. N is the number of the sides of the polygon. Either the question will give it to you directly, or you need to count. You need to count the given polygon to be able to figure out the n, the number of the sides. And by the way, the number of the sides of the polygon will be the number, the same as the number of the interior angle. So whatever you want to count, you just want to count it right, so you get your right value of n. So let's count starting from this side, so I don't count it twice. 1, 2, 3, 4, 5, 6, 7, 8. So n is 8. This polygon is an octagon. It's not the typical octagon that we have in mind, but it is called an octagon since it has 8 sides. So in this formula, all I have to do then is to replace the n with its value. So 180 times 8 minus 2. So here's the tricky part that you see, or I think that students doesn't do correct. They typically do 180 times 8 minus 2, which is incorrect. With the parentheses here in our formula, we need to do whatever inside the parentheses first. So I need to subtract 8 minus 2, that will give me 6, and then multiply the 6 times the 180 degrees, and this will give us the right sum of the interior angles for that polygon. So if you do this, the multiplication, that will be 1080 degrees. I'm just want to remind you, everyone who just joined us and didn't attend the introduction of that webinar, if you have questions, you can type them in the questions box. Let's look at another question dealing with the same concept but a little bit different. The question says, in the regular polygon shown, what is the measure of angle C? So with geometry, it is important to look at the figure and also look at keywords in the question, as it is, with science and other subjects. We need to know why a certain question gives us a certain keyword like regular. So a regular polygon is a polygon with all of the sides having the same length. This is what they mean by a regular. So now they are here not asking us to find the sum of the interior angles, but they are specifically asking us to find the measure of angle C. So this polygon being a regular polygon, the plan is I'm going to find the sum of the interior angles. That's the total, and then divide that over the number of the angles, because all of the angles measure the same in the regular polygons. So regular polygons have the same side length and the same measure of each interior angles. So if I'm gonna divide the sum over the number of the angles, that would give me the measure of each of the angles, including angle C that the question asking me to find. Let's do that plan then and see what we have at the end. So I need to find the sum of the interior angles. Again, I need to find n. N is the number of the sides or the numbers of the angles. So let's count. So I'm going to start from this side. 1, 2, 3, 4, 5, 6, 7. This time n is 7. That makes this polygon a heptagon. So S equals to 180 times 7 minus 2. 7 minus 2 is 5 times 180. Multiply, that will give you the sum of the interior angles in this given regular polygon. So it is a 900 degrees. That's not what I'm looking for. I'm looking for the angle measure of C. I'm going to get that by dividing the sum over the number of angles. So measure of angle C equals to 900 over how many angles? 7. Divide, and that will give you 128.6 degrees. That's it. So this is our answer. So that means that angle C is 128.66 degrees, and also each of the angles have the same measure. Now, this question is a self-check question. You can work on that. It's the same thing that we have done. The only thing that this question doesn't give you a figure of a polygon, but it mentions that this polygon is a regular decagon. How many sides or how many angles a decagon has? So I'm gonna make that question appear with the possible choices, and you are able to choose the answer that you think is correct. And again, those questions are not graded. These are just for your assessment to see if you are good in that topic or you still need some help or some review. So here you go. Okay, so let's go over that question. And really for those questions, I just provide the final answer. If you really want to see that question done, let me know. So the measure of angle X, which is any angle, any interior angle in that regular decagon, that would be 144 degrees. Okay, let's then move on to the next topic if you do not want to see that question. And whenever you get the recording, even if you didn't get a chance to do the question right now, you can get the recording, pause the video on that question, take your time researching on what to do again, and do it, and then compare the answers. If you still have a question, you can email the school and say, hey, this question was part of the webinar. I got that answer, and the answer is so and so. Can you explain why? And certainly one of the instructors will get back to you. Let's get to triangles. How to find an area of a given triangle. In your study units, there are two formulas that you can use to find an area of a given triangle. In that bubble, you will see the two formulas. The easiest one is half times the base of the triangle times the height of the triangle. Or the another not so pleasant one, it's longer, it has a square root. Some students are scared to use that. But this formula is calls for the three side lengths, C, B, and A. This is the three side length of the triangle, and also S. And S here is a value. This value is the half of the perimeter of the triangle. If you remember, a perimeter of a triangle is if you add the three side lengths to a triangle, that will give you the perimeter. This is like the length of the surrounding or the outside of the triangle. Take the half of that, that will give you the value S, and this S is used 4 times here in the formula. When to use the first and when to use the second? Is it up to us, or do we have to, use our judgment, or what determines which one? Let's do the first question, the green triangle here. The given in that question is only the side length of the triangle. If you look at the first formula, the only two sides I need, or two dimensions to be specific, is the base, which can be any of the sides here, and the height. Now, the height in this question is not given. The height is given in the second triangle, the blue one. And I want to go over what is a height or an altitude just to clear the confusion, because some students think that the height will be always a side. Well, it depends on the kind of the triangle. This triangle is not a right triangle. In this case, the altitude will not be a side of the triangle. It will be the dimension that connects one vertex of the triangle to the opposite side, having this dimension also perpendicular, making 90 degrees angle with this side. And this side then we call it the base, and then this side is the altitude or the height. In this question, I don't have the height given, and I cannot calculate the height. I mean, maybe there is some kind of formula I am able to use it, but for the scope of our course, we do not have a way to calculate the height. So the way then we need to find the area of this triangle given the 3 side length is the second formula. So let's see how do we use the second formula, since it's not very easy to use. I mean, it's easy, but maybe the look of it makes some students overwhelmed and feel that they will never get the right answer. So area equals to the square root of S times S minus A times S minus B and times S minus C. It is a habit, and it's a good habit, I think, that we rewrite the formula. I have students, they would go to the question, do not write down the formula from the study unit and try to recall it from their, memory of reading the study unit. I mean, you can be right, but it's safe to just write everything in front of your eyes so you don't miss a sign, a square root sign, anything like that. So first I need to calculate S. S, as we said, is the half of the parameter. Parameter is adding all the side length and then divide over 2. That will give you S equals to 4.5 units. So now I know my S. What about A, B, and C? I can call this side A, I can call this side B, and this side C, whatever you like. Now area equals to, let's now use the numbers. 4.5 times 4.5 minus A, which is minus 4, times 4.5 minus B, which is 3, times 4.5 minus C, which is 2. Easy, right? I'm just using the numbers instead of the variables here. The next thing is, how do we evaluate the expression? Where to start? The way I like to do that is I'm going to evaluate each set of parentheses first. So I'm going to keep the 4.5 the same. Now I'm going to do the subtractions. 4.5 minus 4 is 0.5 times 4.5 minus 3 is 1.5 times 4.5 minus 2 is 2.5. It's getting simpler. Now all I have to do, I'm going to keep the square root sign and then multiply all the 4 values I have here. 4.5 times 0.5 times 1.5 times 2.5. You can do that using your calculator. You will end up with that number under the square root sign, 8.4375. That's not my answer. The final answer is that I need to find the square root value of this number. In your calculator, you will find a square root sign. Exactly looks like this sign. So I'm going to find the square root for that value, and that is 2.903 squared units. So if the length are given in inches, your answer will be squared inches. If the length are given in centimeters, then your answer is going to be squared centimeters, since we are looking for the area. So area, we always calculate that using squared units. Any questions so far? Anything that was not clear on that part of the slide here? Okay, let's move on to the second triangle and see which formula we are able to use. So in this triangle, the altitude is given and it is DC. DC is 4 centimeters, and also they give us the base. And the base is where the altitude, or the side that the altitude is perpendicular to. So this is the altitude and this is the side where the altitude is perpendicular, then BA is the base. So the base is given as 7 centimeters. Well, the first formula, this is the only thing I need. Height and base given, and the half is just a value, use it as is. So I am able to use the formula A equals to half times the base times the height, equals to half times the base is 7 times the height is 4. You can use your calculator or you can do your mental math. Half of the 4 is 2. 2 times 7 is 14 squared centimeters. That's it. Now the second formula is easier, as you see, but sometimes the altitude is not given. So you will have to know how to use the first formula. Any questions? You can type your questions if you have a relevant question that you think that is relating to the slide here. If you don't have a question, let's do a self-check question here. So examine the triangle ABC, which is given in the figure, then answer the following questions. 1. The altitude in this triangle is what? The altitude must be a dimension. It can be a side if you have a right triangle. If you do not have a right triangle, it's going to be just a dimension. It's not going to be a side. What kind of triangle you have here, and where is the altitude? So I'm going to give you that first question. It's going to appear here, and you'll be able to choose your answer. I had a question that if I can go back to the slide before you guys are able to answer. I mean, if I went back to the slide, I won't be able to give you the answer to, the question to answer one more time. So I'll make sure to keep it longer for the next question. Okay, so let's go to then the slide now. You should be able to see my slide. So the altitude is what? Now, BD is not the altitude, so don't get confused by the looks of it, because it may be indicating that it is, an altitude, but really the height is BC. So BC is the height because the same thing, this is how I examine or make sure if a dimension or a side is an altitude. It connects one of the vertices of the triangle to an opposite side, which is correct, and also this dimension or this side should be perpendicular to this side, and that is both of these points are there for BC, so that makes BC an altitude. So BC is an altitude, or you can think of it, well, AB is also an altitude, so that would make the BC to be the base and AB would be the altitude. Yes, you can say that as well. But with the answer choices I gave you, I didn't give you AB. So in that case, BC will be the altitude and AB will be the base. Now the area. What about the area? What do we have already, and which formula you think you're gonna use, and um, are you able to find that area? So I'm gonna leave it for about 30 seconds so you're able to copy down whatever you want, and be able to work on that question. So in a little bit, I'm gonna make the slide disappear, and my question appears on the screen. Okay, I'm gonna put up the question. So the area of the triangle is what? How do you gonna find that? Are you gonna find? Are you gonna use the first or the second? So you're gonna always use or choose the easiest path. If you are able to use both formulas, use the easiest one. I'm gonna wait for everyone to have a chance to choose their answers. Okay, so let me go through this question. So the formula I'm able to use, and it's the easiest one, is half times the base times the height. So whether you're going to consider the AB to be the altitude and BC is the height, I'm sorry, whether you're going to consider AB to be the base and BC is the altitude, or AB is the altitude and BC is the base, you're going to end up with the same answer. So half times, let's stick with the BC being the altitude, and that would make the base BA is 5 times height, or the altitude, is 4. All you have to do then is do the math. Half of the 4 is 2. 2 times 5 is 10. 10 squared units. That's it. Again, if you got that question incorrect, it doesn't mean that it's impossible for you to understand it. It just means that you need to maybe pay attention to some details, go back and read in the study unit, and so on. So let's move on to the next topic. If you're given that polygon and you're asked to find the area of that polygon, you will notice that in the study unit, we don't have a formula for us to calculate polygons. Maybe there exists a formula to calculate the area for polygons, but for the scope, again, for our unit, we're not given that formula. What should we do in that case? Well, I see also they not only gave us a polygon, but they divided that polygon into 2 triangles. And for each one, they gave us the side length for each triangle. So since they want the area of the whole polygon, I can simply find the area of the first triangle and the second triangle, add the both areas, and that will be the area of the polygon. Now the question is, how would you find the area of the first triangle? Which formula? The first one, which has the square root. So for triangle SVU, area 1 equals 2. I'm going to just set up the formula. I'm not going to work out the problem. I'm going to give you the final answers too. So you're going to say, well, 5 minus 3 times 5 minus 3, and then times 5 minus 4. And why do I have a 5 here? Because S is 5. You're going to do your calculations, and then you will find out that the area of the first triangle is 4.47 squared inches. The same thing for triangle STU. area 2 equals 2, I am required to use the first formula with the square root because the only things given are the side lengths. And that formula will be 8 times 8 minus 7 times 8 minus 5 and then times 8 minus 4. Again, in that case, s equals to 8. How did I find s equals to 8? I added 7 plus 5 plus 4 divided by 2. That gave me the 8. I'm going to do the calculations as I said in the previous slide, and that will give you 9.8 squared inches. Now, these are not my final answer. Area of polygon will equal to area 1 plus area 2. You will add them together and that will give you 14.27 squared inches. That's it. So the idea is to use the fact that they broke up the polygon into two triangles. Any questions? Okay, let's look at this question or this topic, Pythagorean theorem. Pythagorean theorem is a special theorems to right triangles. So it does not apply to other triangles except the right triangle. So whenever you're given a question, part of the question or part of the figure is a right triangle, you want to consider maybe using the Pythagorean theorem to make things easier or to find something that you're looking for to that will lead you to something else that will help you down the road. So let's look at this triangle ABC. So again, I need to remind my students that when we have a geometry figure in our exams, even if you are in college, by the way, they do not draw figures to scale. They try to be, they try to be reasonable with their drawings, but if the angle is not specifically mentioned to be a right angle, you cannot assume that the angle is right because it looks like a right triangle. Right angle. They have to have the box here in the corner of the angle for you to be sure that this triangle is a right triangle. Or sometimes you have a base on why this angle is 90 degrees. Maybe you have other theorems that you have used and you concluded that this angle is 90 degrees. This is the case if you are given a figure and that figure has a multi, parts and part of it is a triangle. You're trying to see if this triangle is a right triangle, so you'll be able to use the Pythagorean theorem. Basically, the theorem says, if you square the hypotenuse of the right triangle, that should give you the sum of the squares of the other two sides of the triangle. Where is C? Where is the hypotenuse of a right triangle? Well, the rule says the hypotenuse is the side that is opposite to the right angle. So if the right angle is C, the side that is opposite to the right angle is AB. AB is C, or the hypotenuse. Square the length of that side. That should be the sum of the squares of this side and that side. This is what the theorem basically says. Now the question says, what's the area of the triangle ABC? So with the area, I need either the three side length, I don't have one here that's missing, or I need a base and a height. So one of them is given. One of them here is given. So if I'm gonna think about this to be the base and this is the altitude, I'm missing the altitude. How I'm gonna find A? Use the theorem. Let's use that. So C squared equals to A squared plus B squared. C squared, C is given as a 10. So square the 10, it's not 20. So squared, the 10 squared is not 10 times 2, it's 10 times 10. So it's 100 equals to A squared is missing, is unknown. So I'm going to leave it as is, plus B squared is 5 squared, which is 5 times 5, which is 25. A simple algebraic equation here, we know what to do. We need to isolate the variable on one side and everything else should go to the other side. So how? Subtract 25, do the same thing to the other side to keep my equation balanced. 25 minus 25 is a 0, that's gone. Now I have the a squared is on one side and then 75 on the other side. So a squared equals to 75. The altitude squared is equal to this value. I do not need the square of the altitude. I need the altitude itself. What should I do? Reverse squaring a variable by taking the square root of the variable and the same thing on the other side. So that will give me that a equals to the square root of 75. You can figure this out by using your calculator. It is 8.66 inches. Now I know my altitude and I have the base given already. Which formula I'm going to prefer to use? The second formula, the shorter one, the easier one. So area equals to half times base times the height equals to half times the base is 5 times the height or the altitude is 8.66. Do the calculations and you will find that the area of this right triangle is 21.65 squared inches. Any questions? Okay, let's move on to the next slide, a self-check. Examine the triangle XZY, then find the length of the side YZ. I see that the triangle is a right triangle at Z. I'm missing the YZ, so this side is missing. What should I do? Which theorem I need to use? Okay, I'm going to leave you to think about that and enter your answers. Okay, let me share my final answer. Let me know if you want to see how to do that question. So the length of YZ, we got that by using the Pythagorean theorem. If you do the same things as we did in the first step on the previous slide, that will give you this length, 7.14 centimeters. Anyone wants to see this question or you're fine? If you want to see that, you can just type yes or please, so I would know that at least one would like to see that question. Okay, let's move on to the most challenging topic in this unit. That's what I think. From what I've seen and looked and heard, I think that this is the most challenging topic in the unit. So, typically, you'll be given a question like that. A right triangle, and this triangle QSR is right at S. And then they draw an altitude from S to T. And we know that altitudes are right to the base. So here's a right triangle and here's a right triangle. So now we end up with 3 right triangles. The fact says if you have a right triangle and you draw an altitude, you're making another 2 triangles. So you will have 3 right and similar triangles, meaning that triangle QST and STR and QSR, 3 of them are similar triangles. If you have read the unit already, or if you haven't, we know that similar shapes, they have proportion among their sides, among their corresponding sides to be specific. So our job is to find the length of side TR. TR is that length, which is one side of the triangle TSR, or we can think about it as part of the side length of QR. How do we think about that? We know with similar triangles we need to find corresponding sides. How am I going to find the corresponding sides between the big or the larger triangle and the 2 other smaller triangles? I need to adjust their position so I'm able to identify the corresponding sides. And from there, I can use a proportion to find TR or maybe QR, and that will lead me to TR. So let's see here. So this triangle in red, it's one triangle. The other one is the green triangle. I'm gonna flip and transform the red one so it becomes in an exact position as the triangle QSR. And now when I did that transformation, that triangle, the red one, is QTS. QTS. I'm going to do the same thing for the green one. Transform that so it is the same position as the red and the blue, like this. So I need to label that correctly, STR. Now the 2 triangles are on the exact positions. All the 3 has the right triangle at the top, the shorter side to the left, and the longer side to the right, and the longer side to the left, and then the hypotenuse is to the bottom. Now I can say that QS is a corresponding side to QT. Or I can say that SR is a corresponding side to TS and TR. Okay, now let's put the givens, because there are some givens here. 6 inches for QS. Whatever I see that says QS, that would be 6 inches. That would be a congruent side to QS. So QS here is 6 inches. And remember, QS on the blue triangle is not corresponding side to QS in the red one. Where are the corresponding sides? The sides that have the same position relative to each triangle. So QS is corresponding to QT, but QS is congruent to QS, and that's why we have it 6 inches here. QT is given as 5 inches. Whatever I see in other triangles that says QT, that will be a 5-inch side. Now, how I'm going to use the fact that they are similar to find the TR, that side? Okay, we're gonna work with proportions, and we have to set up our proportions correctly. So I'm gonna do QS over QT. So QS here comes from triangle QRS. QRS is the blue triangle. So everything on the tops, because I'm going to have another fraction here, this value or this side and this side will come from the blue triangle. Now the bottom values, the denominators, will come from the red QST triangles. Now QS is corresponding to QT on the red, right? That is correct, QS and QT. What other pair of corresponding sides that I'm able to use, that they have the side length given to me? Well, QS, I know that QS is 6 inches, so I'm going to use that. I'm going to put it on the bottom. And now QR is the corresponding side to QS. Do I know the side length of QR? No, I just know part of it, QT. Okay, so maybe when I find the total length of QR, I have already what QT is. I can do subtraction, and that will give me TR, which is what I'm looking for, equals to. Let's then use numbers instead of side labels or side names. 6 over 5 equals to, QR is unknown, over 6. The way I solve proportions, and I think it's easy way, is that the unknown value will equal to cross multiply and then divide. Cross multiply the known values and then divide over the remaining value. So that will give you QR equals to 6 times 6 over 5, and that will give you 7.2 inches. What is 7.2 inches? QR, 7.2. What about TR? Well, TR equals to QR minus QT equals to, QR is 7.2 minus 5, which is the QT, and that will give you 2.2 inches. This is TR. So TR is 2.2 inches. That's it. It's hard, I know, but when you get the recording, you can, take it step by step. The most challenging thing here, or a step in this question, is to find out the corresponding sides. And the way to do that is we need to draw ourselves the triangles outside. Just take the two triangles, the red and the green, outside of the main triangle, the blue one. Transform these triangles so they have the same position as the given one, and from there you'll be able to identify the corresponding sides. Any questions? Anything that was not clear? It's hard, I know, but if anything that was not clear. Okay. Okay, so let's go to then similar polygons. Similar polygons. You notice here we have a proportion. So whenever we speak about similar triangles, similar segments, similar polygons, we will have to use proportions. Okay, let's read the question and try to put the givens on each of the figures. One side of a polygon whose area is 24 square meters is 7 meters long. What is the length of the corresponding, see, similarity, corresponding side of a similar polygon whose area is 72 meters squared, or squared meters? So obviously the 72, the one with the bigger area, would be the larger polygon, and we are missing this side. Let's call it X1 is missing, and that's area 1. Area 1 is 72 squared meters. Now the smaller one has an area 2, of 24 squared meters, and that's area 2. And the corresponding side here is there. See, this side is opposite from this angle, and this side is opposite from this angle. So this is the corresponding side to this side here. And X2 is given as 7 meters. what would be the side length of the corresponding side here? x1. Use the formula. So all I have to do is use the numbers instead of the symbols here or the variables, and then solve the proportion. So A1 is 72 over A2 is 24 equals to x1 squared is unknown because x1 is unknown, over x2 squared is what? x2 7 squared is 49 because 7 times 7 is 49. So I have proportion, I have one unknown, the same thing I did in the last proportion is how to solve that. So x1 squared is the unknown, cross multiply, divide. So multiply and then divide. That will give you that x1 squared equals to 72 times 49 over 24. You do the math and you will find out that x1 squared equals to let me check my math here real quick just to make sure I have the right figure. So 72 times 49 equals 2, and then divide over 24. I have it right. So it is 147. Now, I'm looking for x1, not x1 squared. So I need to do what? Take the square root of both sides. So I am having the value of x1 equals to the square root of the number 147 will be 12.124 meters, which is this side, and that's it. So all I had to do is just know how to use the proportion. That's it. Any questions? Okay, let's do one self-check on the similar polygons. What is the length of the corresponding side? So you have an area of 50 inches squared or squared inches. The other one is smaller, 15 squared inches. One side on the bigger one is 10 inches. So the corresponding side is this side here, and you need to figure out the side length here. So I'm gonna let you do that. And just to give you a hint, you need to label each polygon or each area with a polygon, if area 1 or area 2, the sides with x1 and x2, and from there you'll be able to easily use the proportion. Here you go. Okay, let me share my final answer and let me know again if you want to see this question. You will figure out that x2, which is this side, equals to 5.48 inches. Anyone would like to see this question? You can type please, yes, so I would do that. Okay. That was it for my math here section of the webinar. We went over how to find interior angle measures, either the sum of them or just one specific interior angle if the polygon is a regular angle. I'm sorry, is a regular polygon. Also, we learned how to find the area of a triangle two ways, and we knew which one to use in which case. We learned about the Pythagorean theorem, that it is special for right triangles, and we learned how to use it. And also we looked at similarity between triangles and also polygons and how to solve and set up the proportions to find the unknown length. For the exam, please read your study unit. Please do the practice exercises within your study unit. The answers key are provided for those questions. So if you are working in the daytime and you do your schooling at night, you don't have to wait for the school to open, for example, to make sure that your question is answered correctly. You can refer to the answer key. And those answer keys are in a separate document within your course. You can download that PDF document and it has the answers for all of the questions. So the way to use that is go over the practice questions yourself first. Keep a notebook, of course. I mean, keep your work organized. Once you're done with a bunch of practice exercises and you feel like something is wrong, maybe you're not sure, go to the answer keys and check your answers. If your answers are mostly correct, it's a sign for you that you're ready for the exam. If the answers are mostly incorrect, it means that you should not attempt the exam. You should go back to the study unit, study more, do the practice questions, look into the questions that you didn't get right and see which step on those questions that you missed. Maybe you didn't square, maybe you didn't take the square root, maybe you didn't subtract right. Resources for that course. You can email the school with questions that you have. You can call the school 9 to 6 Eastern Time on weekdays. And also there is a live help or office hours for geometry, 2 to 3 Eastern Time on Wednesdays. So there's no registration needed for the office hours. You can just use the link and you can bring in a question from the course. It should be relevant to this course, and the instructor can go over that with you. KhanAcademy.org, it's free, and they have neat and instructional videos on every topic that you can think of on math, and you're able to watch these videos, and I'm sure you can find something that you really like and useful for you. YouTube, free library for us. You can type in the topic that you're not sure how to do. So you can type in how to find the area of a triangle. Bunch of videos will pop up for you, and I'm sure something also useful will come up in the list, and you'll be able to learn more and be sure on topics before you attempt the exam. Thank you everyone for participating and attending, and thanks for everyone who registered for the webinar. And I understand that you guys work, have other things to do besides school, which is make me proud of you that you do many things in life besides schooling. So you will receive this recording whether you attend today or no in a follow-up email in a couple of days. If you don't have a question for me, I'm going to wait for 30 seconds to think of a question, and then I'm going to end the webinar. Okay, thank you, Mallory. Well, I wish everyone do great in the exam, and hey, if you didn't even do great in the exam, I mean, it's not the end of the world. You can do, you can improve, you can study more, you can ask questions. Good luck, everyone.